Thank you. The title of today's lecture is inspired by this Corona time towards the third wave of software testing. First of all, we have to look at software testing. There are a lot of definitions for software testing, but the basic definition that we can get from IEEE is the activity performed to evaluate product quality. So this evaluation is done by finding defects or problem in a software product. So failure or defect or all those names in software testing leads to different problems, starting from simple problem like a program crash or a software crash, or going on with losing data, or maybe losing life also, and losing money and fortune and so on. In my vision, there are three waves of software testing, research and development. And my presentation is going through these three waves and how my research and my colleagues together, we allocate our research into these three waves, and where we are going with software testing and where we are going also with the research, what are the ideas that we have in our mind. So the first wave that we can recognize is, in general, software testing started early 80s. And then later on, we can recognize from the literature that the first wave started with the test automation. And then if we look back to the early days of software testing and how we started like putting ourselves as a testing community into the general software development, and how we started with the requirement document, and then developing a test plan, and then generating a set of test cases manually by that from that test plan, and then apply these test cases manually. That was the early days to apply and execute the software, the test cases on a software under test, that what we name it. And then we realized that running all these test cases again and again when you have some change on your software, it's not realistic. So you have to have some mechanism to record your execution and then rerun these test cases. And that was the initiative of the idea of capture replay tools. And then you run the test cases, but you are recording in the background, and then what you have is that you can run again the test cases later on. And then there was another idea, which was the development of that idea, still in the same software development process, but making this testing as a keyword, and then call the keywords, because changing these test cases from time to time with the change of the software of the software product is not realistic also. So what happened is that using some keywords and then call these keywords, and then these keywords are representing the testing, the abstract testing scripts, and also representing the software part. And that was the starting idea of model-based testing, in which my research also is there. So the model-based testing started by modeling some part of the software or the whole part of the whole software. And then starting from that model, you can convert the model or part of the software into mathematical objects. And then when we, like, for example, a matrix and so on. So then the software testing community, the whole community, started to think about using AI methods to deal with this mathematical object. But let us see how we get up with this idea of AI method then. And then we start using, and still we are using all these three concepts together, the AI methods, the model-based testing, and the mathematical objects into one testing framework and testing strategy. Me personally and my colleagues, we started early with the modeling, different part of the software. And then what we had during that time was that model the configurable software or software product line to some kind of model, and then convert that to mathematical objects. However, we found that you cannot generate all the test cases because the current software development leads to a lot of functionality, a lot of inputs. Then we end up with something like combinatorial problem. And then we realized, not me, also the research community in software testing, we realized that we need a clever sampling of these test cases. So we have to have some strategy to select the test cases, not all the test cases, but the test cases that matter to the testing. And that was, in my opinion, that is the second wave of software testing, using AI into the software testing. So the idea of software testing is the same from the beginning until now. You have a software, you have some set of input, and you apply this set of input, and you are monitoring to see what is happening now and what happened in the software as an output. However, we found that running all the possible inputs, it's basically impossible and exhaustive. But selecting, having a strategy to select the best or the test cases that matter to the software is also difficult, because you have to set some criteria to this selection process. And that was the idea of goal of testing or criteria of your testing. So once you have this criteria, for example, how many faults you got in your testing process, or how many lines of code you are covering by each test case, and so on. And then you have many criteria. And then once you have this criteria, it means that you can have a measure. And then when we can measure this criteria, that was the starting of the idea of search and optimization, that we call it sometimes search-based software engineering or search-based software testing. So the idea is you have a goal, you set a goal for yourself, and then you measure that goal, that criteria, and then you have a set of test cases, and you evaluate these test cases again and again until you get the selected, the best test case. So this idea, basically having this measure, means that we have an objective function. And in AI and optimization algorithms, this is very important. Since we have an objective function, then we can deal with this objective function as an optimization algorithm, an optimization problem. So you have some iteration, and then you enter the test cases to that iteration to evaluate them again and again against some measure, which is the objective function. And finally, after some iteration, you will get the best achieved so far, the test cases that you have. So using this idea, you randomly generate a set of test cases, and then by iteration, you manipulate according to the achievements, according to the measurement, and then by iteration, at the end, you will get the best achieved test suite, which is the set of test cases. Now, this idea, since we can apply this idea, it means that we can create tools that can be plugged to the software under test. And then these tools can have a complete strategy from the beginning to the end, taking the input, define the measure, the goal, and then generate the test cases. Now, this idea leads us to a lot of research here in two directions. One direction is to use different optimization algorithms during that time, and also to use to develop new optimization, or as we can say that improve the current optimization algorithms for the new software applications that we have. So we started early with test generation, with particle swarm optimization, and then we moved on with changing the input to variable strength input, and then using particle swarm optimization, and then taking variable strength and flexible strength, let us say, to use it for particle swarm. And then we use that for, we use cuckoo search, for example, for test generation. We improved the particle swarm part by having a feedback and to generate, to have an adaptive way of test generation and optimization by adding the fuzzy logic to the particle swarm. And then we had teaching learning optimization, and then we had constraint for the inputs, and a lot of other research like hyper heuristic to generate inputs, and Monte Carlo based hyper heuristic also, and finally some other algorithms like Henry Gas and so on. So this area leads us to develop new methodologies also for testing for software applications. Like, for example, not only using the inputs, but also using the internal code structure of the software, and then using mutation to inject artificial faults to the software, and then also use process testing to consider path of the software, specific path of the software, and then business model based testing. And all these ideas leads us to developing a new automated framework, testing framework, named Avocado with Red Hat, and plugging a lot of our methodologies there. So you can see that we used code-aware combinatorial interaction to look at the code. We used code coverage for testing with constraint solvers. We used defect injection. We developed defect injection. And then we had the Avocado, which is open source flexible constraint interaction testing. And then we had the fully automated the framework for testing. And then also we had like business data, using business data for testing, for generating static tests. And then we implemented also algorithms for path-based testing to take different path of the software or specific path of the software. Now, this model-based testing idea also leads us to a lot of research, not only our group and other groups also, into user interface testing. And then you can see that the concepts are the same. You have model-based testing, you have AI methods, and then you have mathematical model. These three components are always available in any testing strategy of our research. So what we did here also is like automation of graphical user interface testing by taking the model of the input of the clicks and the events and consider these as events and create a model for this graphical user interface. And then also take this model-based testing to mobile application testing by modeling the clicks of the user on the mobile application, and then create a model for that, and then start from that model to create a mathematical model and use AI to generate test cases based on that. And then also for web application testing, we use the same concept, but using also different users to create a model for the web application and then combine all the models into one mega model and deal with that model. You can see that this mega model we generated for some specific website, and then you can see it's really complicated. And then you can consider, you can start from some point and generate a test case based on some path you choose for your clicks on your application, on your web application. And then an innovative idea that we had for testing was smart TV application testing. Recently we tried, and this was really challenging because you have to consider the remote controller to generate the to construct the model and then generate the test cases based on that model. And you can see that remote controller is not easy because you have to go one step and one step each time when you press the remote controller, and then you cannot go directly from a button to another. And then that is also a challenging process for creating the model, and then also how to generate a valid test case, not only going from a button to another, also going considering the path, the true path that you have to go from one button to another. And then you can see that we created a really big model called mega model, and then how to use AI to extract this model and how to use AI to take this model and generate the test cases. Also, these are really challenging problems. And then here we had a lot of research, like using simplified swarm optimization for graphical user interface functional testing, and then for mobile application testing, and then the Evo Creeper, which is our creeper to our tool to generate test cases and model for mobile application testing. And also this one, automated testing framework for smart TV application testing. And then for the first time using modeling or model-based testing for usability for smart TV application testing. And then from here, you can see that we are talking still on the application level, that we are talking about one single software on a single software application on a computer. However, the current movement of the software testing is going toward the system level testing, which is quite challenging. And that is what I call the third wave of software testing. Now, imagine that you have an IoT system, and yes, it's true that you can consider this IoT system from different perspective, but what if I consider it from software perspective? So you have different nature of software. Here you have distributed software somehow. You have a lot of data entered, and then you have testing in scale, which is really challenging. How to consider this? And then the relationship between the software application and the system. You cannot extract the software from the system. A lot of fault may come from the system, not from the software application. And the analytic part of this system, this is the current challenges that we are in the software testing community and also in our research focusing on. And then we had some initial research here, like, for example, what are the quality attributes of Internet of Things from a software perspective? And then when we can define these quality attributes, that is the measure that we talked about at the first slides, that when we have that measure, then it's easy to quantify our test cases if we generate test cases. And then current challenges of quality assurance. And then all these papers summarizing, trying to summarize all the quality attributes. And recently we tried this path-based testing for IoT testing, and then how to take this path in the IoT for software testing. And then recently also we had the Patriot, which is an automated testing framework with Red Hat company. Now you can see that the idea is still the same, but the question is also how to transfer or how to reuse the current or the implemented and the classics in the software testing into this third wave of testing. Now we are moving also toward AI engineering, which is really, there are a lot of synergies. However, there are a lot of challenges here. So for example, we in the software community see the data science lifecycle as a software engineering lifecycle, but with some synergies. So there are a lot of synergies between data science and in general and software engineering in general. And then there are a lot of challenges now. So for example, how to deal with this data-centric applications. Then, for example, incomplete data gathering, inconsistent data storage, and then misleading decision-making, and then how this data contribute to that, and then how to transfer the engineering concept of software engineering into the machine learning and data science. And you can see that the software engineering community started looking at the machine learning and specifically and AI in general as a software product. So we see data as a software product. We see the machine learning as a software product. In a recently published paper, you can see how many areas that we can try with the machine learning and AI engineering in general, how to apply, how to engineering the AI. It's not about taking a package of AI and apply it on a set of data now. It's about a system thinking and how to engineerize this one, if we can say that. There are different parts, and taking it from the software perspective and software testing perspective, we are talking the same in the same area. So as we said, the AI engineering, the software testing and the software engineering in general, taking the requirement, and then you have the requirement specification, and always you have validation and verification. And it's the same idea when you apply the machine learning. You have, if you consider this, you have the same idea. So that's why we are looking at the machine learning and the AI in general as a software product. And when we say it is a software product, there should be the same methods that we are applying, but with a different nature that we have. Now, what is our vision here for research? We have a lot of goals, actually, and in general, in software testing community, we have a lot of research is going on here. For example, like what we are specifically looking now with our student is that how to look at the model degradation of the machine learning, how to see that the model is degraded, how the data streaming is contributing to this model degradation. And all these are problems without answers, basically. And how to apply the testing concepts into this process, how to generate test cases for machine learning algorithms, how to verify the data based on a set of test cases that you apply periodically. So all these are questions. And then how to identify the pass and fail criteria, because in the machine learning, we don't have currently we don't have a formal requirement document for the machine learning product. So when you don't have the requirement document, how to define the pass and fail criteria for the test cases that you have. And finally, we can see that there is a lot of things going on in software testing nowadays, and we have a lot of direction to go. What we are looking for nowadays is totally different from what we have looked for during 80s. We started, for example, the software testing community in general started from waterfall methodology, and then we improved to waterfall with feedback because there were like a lot of problem with the testing in the waterfall. And then we went on to different area. Now the third wave of software testing is really interesting because you have other objects entered to the software testing. We have AI, how to use AI for software testing, and then how to use software testing for AI. It's really complicated question. And then how to apply or adapt the classics in software testing into these new areas that we have, these new application that we have. So the data-driven system is really complicated. Also, how to move all these things into cloud, and then how to use cloud resources for testing. It's really complicated also. And then security testing, it's not my area, but it's also a challenging area that it's promising in the coming years also. So in the internet scale in general, it's really complicated, and we have to consider a lot of factors, not only the software installed on one computer. So you can see that the whole idea of software testing is changing. And then the software testing community also is trying to adapt. And also you can see that the idea of AI engineering is now a hot topic because you can, for example, what is the agile process of development for machine learning algorithms and machine learning systems, not only the algorithm. And then what is the best software architecture for machine learning systems? And there are a lot of things to consider in this area. And I think we can adapt our methodologies that and the classics of software engineering into the AI engineering also. So finally, I have to thank all my collaborators around the world, actually. So during my PhD, my supervisor, and then during my postdoc, my supervisor in Switzerland, and then all my collaborators. I really appreciate working with them, and I think it's a good time to appreciate also to thank these people. Thank you very much. That's all I have now. Thank you.